So welcome back to the introduction of IBM SPSS Statistics. This second section will show you how you can prepare data for further analysis. We call these procedures as data transformations. There are a lot of these data transformations, and we will introduce only three of the most common. First one will be discussion about recoding, and then I will show you how you can proceed procedure which is called compute. And the last one, procedure, which is maybe not so common as recoding as computation, is about counting occurrence of individual codes in the set of variables. So let's start with recoding procedure. It is possible to use for two possible purposes. First one, and I would say the most common, is that you take existing categorical variable and you try to change coding scheme of this categorical variable. Second option could be that your original variable is cardinal by its property, and you try to prepare intervals or ranges from this cardinal variable. I will show you this example later, and now we will try to make recoding for some categorical variable. So before we would go further to computation, let's go to IBM SPSS Statistics, and once again we will use a short piece of European value study data which were collected in the Czech Republic in 2017. For recoding in my data, I would propose to take simply the variable which is based on education level. This is the last one variable in my data set. The technical name is V243 and underline is CAT1, so it means it is based on International Standard Classification of Education. And substantive code that could be interesting for us and that could be ideal for recoding starts from 0, which is less than primary education, and finishes at 8, which is doctoral or equivalent program at university. And let's imagine that for further discussion, I do not need division into 9 individual codes for the highest achieved education, but I would like only to differentiate people who at least follow some university degree, so it means code 6, bachelor or equivalent, 7, master equivalent, and 8, doctor or equivalent. And I would like to discriminate only between those who achieved at least university education and all the rest. So ideally, I would like to prepare a new one variable which will be measuring whether I achieved or not at least some level of university education. For simplicity, I will propose that code for those with university education, so it means originally 6, 7, and 8, will be code 1. And for all the rest with no university degree, so it means originally from 0 up to 5, I would use code 0. We call this variable with only 2 options as binary or sometimes dichotomy, so it has only 2 options. So let's start with recoding. We know that we would like to merge categories from 0 up to 5 and 6 up to 8 to codes which will be 0 and 1. So if I like to transform data, I need to visit the procedure which is called simply transform. And here there are 2 options for recoding. Recoding into same variable and recoding into different variable. Be careful and usually use recoding into different variable, as if you apply recoding into same variable, you will exchange the column in which you have your original data, and there is no chance to go back. So ideally, we would create new one variable. Technically, SPSS every time will prepare this new one variable as the last column. So it means it will be here present in my data matrix. So let's go back into transformation, recoding into different variables, and let's see how to proceed this recoding. First of all, we need to take the last one variable, which is measuring original education level by 8 codes. So move it to this window. And next one, we need to specify at least technical name of new one variable. As it will be description whether I am not or I am university educated, I propose simply use technical name as uni, stands for university, edu stands for education, and by clicking into change, this question tag will disappear, and you know that from original variable with 8 codes, I will create university education variable. You can also add a label, so it means variable label, but it's not necessary, I guess, in this case. And you need to visit the second option, which is called old and new values. So for us, it's necessary not to take original values and redefine as new values, but we need to take range. So the first range will be from 0 up to 5. So it means those with no university education. And new one value, as I proposed, would be 0. So from 0 up to 8, recode into 0. And by clicking into add, you will take this first condition for recoding. The next one condition will be code 7, 7, and 8. So it means from 6 through 8, it will be recoded as 1. And if you do not add any other rule here, SPSS automatically create system missing values for all other cases. So it means for those who didn't discuss about their level of education, automatically SPSS will ignore these cases. If you like, you can also specify more rules here, but for us, we need only these 2. By clicking into continue and OK, SPSS automatically will compute by recoding new one variable. So let's see that it works. Here we have university education 1, as original code was 7, which is master degree. 3 is 0, it's not university educated, etc., etc. And if you go to the line number 11, you can find that original code was -2. I guess it was no answer. And as we didn't define any rule, system missing value or point is present here. So it means SPSS will ignore this case. Last one, recommendation is every time you prepare new one variable by recoding, it is always good to check whether your recoding is correct or not. Ideally, let's take original frequency table and new one frequency table and compare results. So if you would like to see frequency tables, let's go into Analyze, Descriptive Statistics Frequencies, and last 2 variables will be included into my computation: original education level and university educational. That's it. Click into OK, and now we can check our results. First of all, let's see that 17 system missing values are present in new one variable. And originally, there was 2 cases with don't know, 15 no answer, in total 17, and these 17 are here, as we didn't specify any rule for no answer and don't know. And now we can try some brief computation. Ideally, let's start with bachelor or equivalent, master or equivalent, and doctoral. So 58 plus 231 plus 12. And if you sum up all these values, you can check it, you would get the value 301. So it seems to me this is also correct. And the last one number must be also correct. If you do not believe, you can sum up from less than primary up to short cycle tertiary, and all these will be together 1,493. So seems that our recording was successful. Next one procedure we will learn to use in data transformation block is computation. Computation is mainly designed for cardinal variables, and it is based on mathematical formula, and you compute new one variable by some mathematical formula. So you can take one or more cardinal variables that are present in your data. Sometimes you can use also binary variable, and you can make computation. Very easy example and very common for social science data will be based on the variable which is present in a variable called V226, and it is year of birth of respondent. If you go to this variable, you can find, for example, the first respondent. It was she, at this present code 2 for female, and she was born in 1982. The next one, 1960, etc., etc. But I would like to know what is the age of every individual respondent in the year in which data were collected, 2017. So mathematically, I would take 2017 and subtract the value of V 226. But before any computation, every time be careful and let's check your variable and at least check if there are maybe some missing values that should be omitted and maybe some strange values that should be also omitted from the computation. It is very easy for us to see variable information for V226, and you can find codes -10, -8, etc., etc., multiple answers, etc., don't know. And there is also some special code 1937, which stands for I was born in 1977 and before. So all these information from -10 up to 1937 should be omitted from the computation. And if you do not proceed this system missing value definition, then also your computation of age would be totally rubbish. So I would need to define that from -10 up to 1937 should be omitted and then start computation. So I would need to skip into variable viewer, so left down part, and I would need to go to line number 22, and for year of birth of respondent, define missing values. So I would need to take range, and the lowest value is code -10, and the highest that should be omitted is 1937. And if I click into OK, all these will be ignored from the computation. If I go back to data viewer once again, I can run computation currently. So let's go into transform, and the first one procedure is for computation. Here it is. First of all, you need to specify technical name of newly computed variable. I would propose simply to use age, and then maybe no variable label is necessary. And the next one is that you apply the formula. So you can type here, you can use also this small keyboard. So I would type 2017. And if I'm not sure about variable name, I can only take this year of birth respondent and move it by this arrow, and it will type for me V226. And now I can click into OK. Once again, new one column on the right side of my data matrix will appear, and I hope it will be age of the respondent. So once again, I can check my results. So here it is. This last one column is the age. And for the first respondent, she was born 1982. And in 2017, she was 35. Seems to me correct. Next one, 1950, 57, etc., etc. And once again, you can find, for example, the case on the line 21. And as there was no information about his year of birth -2, sorry, it was her, then there is system missing value. So it means if there is missing value at the beginning of the computation, there is also missing value, system missing value in the end of the computation, so it works properly. Last one check that could be added here would be that I would go into analyze descriptive statistics, and for cardinal data, maybe descriptive is the best option. So I can go further to the age and run the procedure. And I can find very simply that for my data, minimum is 18, maximum 78, as usually UVS is designed for adult people. So it seems to me that my computation should be correct. And I would add one more example. So I would go back to this recording, and I will show you how I can prepare some intervals from cardinal variable. We will also utilize this newly prepared variable later in recording devoted to correlation. So if you can save these data, you can use it for future. And my proposal would be, if I currently can use the age, I can divide people into individual ranges or intervals by approximately 10 years. So as the youngest respondent in my file is 18, I'll propose the first interval would be from 18 up to 30, then 31 up to 40, etc., and then 60 plus will be the last one category. So here I have original age variable, and I would like to create new one variable, which would be called age cut, stands for age category. So once again, transformation, we will be recoding into different variable, and new one variable must be defined. So I would reset all this previous dialog, and now I would take age as the source variable, and new one I would call simply age cut. Click into change, and now it's necessary to define rules, so all the new values. Once again, range from 18 through 30, and I would code it as 1, the youngest category of people. Next one would be 31 up to 40, and I would use the code number 2. Next one, 41 up to 50, and it would be code number 3. Once again, add 41, so next one is 51 up to 60, and I would use the code 4 and add. And the last one, definition, if I remember properly, 61, and maximum in my data is 78, and the code design for this latest category of age, I would propose to use code 5. Last one step would be to define also value labels for better understanding of my result. So I would click into OK, and I can check that there is new one variable age cut. For example, you can find that somebody who was 35 is in the category number 2. Seems correct to me. 57, number 4, etc., etc. So you can check some of these values. And last one, as I proposed, is to go into age category and add a value label. The simplest change into variable viewer is double-clicking by left button on individual column. So we are here in variable viewer, and I can add values, all value labels. So the first one category will be number 1, and these people are from 18 up to 30. Next one will be number 2, and these people are 31 up to 40. Next one, code number 3, and 41 up to 50. Next one, category number 4, 51 up to 60. And the last one category, I would type 5, and the label would be 61 plus for simplicity. And the last one step, I can check also my newly created variable. Let's go into analyze, descriptive statistics frequencies, and I can once again reset this dialog, and I can take age category as newly created variable and check individual frequencies for these categories 18 up to 30 up to 61 plus. And here we have 147 missing values, as we have also some missing values for original age, I guess. So seems to me that's correct. So that's it. And the last one procedure I would like to show you in this data transformation block is counting. Counting is usually designed for categorical data, but you can use it also for cardinal data if you like. And it is trying to find the occurrence of specific codes in the set of variables. So it means counting is every time related to more than one variable. Sometimes you can use for the same task also computation, especially if your variables will be coded 0, 1, computation of sum and counting will give you maybe the same result. And I will show you a simple example for this counting procedure, and it will be based on the first set of variables which is present in my data. So variable V9 is discussing if you belong to a religious organization, V9 if you belong to some organizations that organize cultural activities, etc., etc. And the last one, V19, is if you belong to some other groups that are not mentioned previously. So it means here we have 11 variables, and you can belong to 1, 2, 3, up to 11, or none of these organizations. Every time code 1 is if somebody mentioned he or she is a member, and code 2 if he or she didn't mention. So it means if you would like to know in how many organizations you are involved, it is enough to count the occurrence of these codes, number 1. Let's see how it would work in SPSS environment. So let's go to the first case in my data, and let's try to see from V9 up to V19 how many codes 1 I can find. 1, 2, 3, 4. So it means that for the first respondent, he or she is involved in 4 different groups. Next one is interested in none of these organizations. So it means 0 would be final number, etc., etc. And this counting will try to find number of occurrences of this code 1. So it means I will try to find in how many organizations I'm involved. So let's see how to proceed this counting in SPSS. Let's go into transform, count values within cases. And first one, it's not difficult to understand from previous dialog, is that you need to define technical name of new one variable. So if it is number of organizations, so I will propose simply type NUM, then underline, and OR as organization. So here it is. And I would need to take all these variables. Maybe I will change by right button to variable names from V9 up to V19. And I would like to find the occurrence of code 1. I discuss that I am member of individual organizations, so define values, and I would like to find code 1. You can find that you can also find codes in some range. You can find, for example, if there are some missing values, system missing values, or user missing values, etc., etc. It could be very useful, for example, to find in how many variables there are missing values. So it means if there are most of these non-responses, then maybe this respondent is not very useful for my data analysis. So I would take code 1 and add to the list of the values to count. Click into continue and click into OK. And I can find in my data matrix, of course, new one variable, and it will be once again on the right-hand side. So here we have for the first respondent 4 organizations, for the next one 0, 0, etc. And last one check that should be added is that you would like to check minimum and maximum value of this number of organizations. If there are 11 variables, so maximum could be 11. And the lowest number would be 0. So if you check by analyze descriptive statistics and descriptives, newly created variable number of organizations, I would replace age from this procedure. We can check if my results are correct. Minimum is 0 and maximum 11. And for example, the average, which says on average or average people in my data set follow only one organization, that's also a substantively interesting result. So that's all about data transformations. Next lecture will be devoted to descriptive statistics, and then we will move to some basic analytical procedures such as t-test and correlations.